Okay, so to calculate the molar mass of potassium iodide, we write down the symbol for K, potassium, and we look on the periodic table, find its atomic mass, 39.0983. We find the atomic mass of iodine, 126.90447. We're going to multiply both of these by the number of them we have in the formula. We have 1 potassium and 1 iodine. We're going to add those together, being aware, because I've lined up all the digits vertically very carefully. I can see I have an empty slot on the right. That's going to tell us what we need as far as significant digits for this problem. So we're going to add together then 39.09, we've got 2 zeros here, 0983 plus 126.90447. I get 166.00277. This is addition, so any digits to the right resulting from an empty slot get rounded off. So we underline the 7 to show that it's insignificant. Draw an arrow to show that we're rounding off. Get 166.0028, and we have to write grams of potassium iodide equals 1 mole of potassium iodide. In this class, this is required, that you finish the calculation of molar mass in this manner. All right, to convert then from grams to moles, because we need to have our final answer in moles per liter, because we're trying to find molarity, we need moles per liter. To convert from grams to moles, we're going to use this equality statement. We want to match these units and species with the side of this equality statement and put that side on the bottom of this fraction. And put this side of the equality statement on the top of the fraction. This fraction is now a conversion unit, and it's called a unit because when we put the same numbers that are equal top and bottom, it equals 1. So because I have units that are the same on the top and bottom here, I can cancel them. Because I have species on the top and bottom that are the same, I can cancel those, like x's and y's in algebra. And we're ready to start doing the math. We have the setup now the way we want it. We want molarity. Molar concentration is molarity. We have our solute on the top in units of moles. Solute on the top here in units of moles. We have our liters of solution on the bottom. Liters of the Ki solution is on the bottom. We're ready to do the math and find an answer. And the way I've taught you to do this kind of math quickly is to put in the 1.47, and since I'm multiplying by 1, I really don't have to multiply, so I'm ready to divide what's on the bottom. Divided by 7.65, and go ahead and hit enter, and then divide by the other thing that's on the bottom, divided by 166.0028, enter, and this is the answer that I get. And I hope you got when you did the math. 0.00115519337, and we have units of moles, Ki, and units of liters, Ki solution. That's what's left in the problem. We didn't cancel those out. We got to keep them here. Now, this actually comes out to be molarity here in a second. I'm going to show you that. First, I want to round off to the correct number of digits. Since I have multiplication division going on here, I want to choose the measured or calculated number with the least digits. This, and this. Those numbers are measured or calculated. These two are measured. This one's calculated. You want to choose the one with the least digits. Both of these have 3. Our final answer needs to have 3. Leading zeros are not significant. So our first significant digit is the 1 here. 1, 2, 3 significant digits, and underline from there over, starting with that 7. And we're going to round it off then. And we have 0.00116. The 7 makes the 5 round up to a 6. Since moles of Ki over liters of Ki solution fits what molarity is, we can use this symbol instead of all of this. So we can say molar concentration of Ki solution. Okay? You got that? All right, so here's a chance for you to practice. Okay, so with 3.33 grams of methanol, I even gave you the formula here, because we in this class at least didn't do these kind of formulas back in Unit 4. So methanol, this amount of methanol is dissolved in 22.22 liters of aqueous solution. What is the molar concentration? Okay, so the pattern is the same here. You've got to convert your units of grams into moles. You've got liters of solution, so you're ready to do the math. Time for you to practice.